Hiya and welcome to our tutorial on linear sequences. Today we're going to be looking at the nth term. I will be covering this across two videos. The first one will be covering the first four questions, which is what is a linear sequence, what does the term-to-term rule tell us, what is the nth term, and how do you find the nth term. So what is a linear sequence? So a linear sequence is one where we are adding the same value each time. So this is also called a common difference. So between 7 and 11, there's a difference of 4. Between 11 and 15, there's a difference of 4. So I'm adding 4 each time. So it's also called an arithmetic or arithmetic sequence, and it means the same thing. I'm just adding the same value each time. Another reason why it's called a linear sequence is because if we put these values on a graph, we do get a straight line. Okay, so first number is 7, second number is 11, third number 15, and then the fourth number, you'll see if I connect using a straight line, happens to be just over there. So it's on the same line. Okay. Right, so what does the term-to-term rule tell us? So each member of a sequence is called a term. So these numbers are all terms of the sequence. And so the term-to-term rule is what I've actually written here. It just tells me how to get from one term to the term that is directly after it. So it's the term-to-term rule. Moving on. What is the nth term and how do you find it? So I'll use the same example as the page before and do a couple more. So we've got the numbers 7, 11, 15, and 19. Now if I asked you to tell me what the 50th number in this sequence was, you could start by adding 4, and you'd add it 49 times until you got to the 50th number, and that would be your result. Now there's another way that we can do with much less steps, and that's by using the position of that number in the sequence. So n here means the position. That's why it's called the nth term rule. It's also called the position to term rule. So this n is just the position in the sequence. So my third term, 15, n is 3. My fourth term, 19, n will be 4. So in order for us to find the nth term, which is sort of a general rule, we need to use what we already know. So the first thing we know is it goes up in 4s. What we also know is there's another sequence that goes up in 4s, and that is the 4 times tables. So 4, 8, 12, 16. Now we can use the 4 times tables. We can use the position to find any number in the 4 times tables. So if I asked you what was the 11th member of the 4 times tables, you would then say 4 times 11 is 44. Just like if I said what's the 4th member of the sequence, you'd say 4 times 4 is 16. So we can find any member of this sequence by saying 4 times its position n. So once we found that that's 4n, we can then make the link between this sequence 4n and our original, and we do that by comparing, and we can see that to get from 4 you add 3. Now you only need to do that first term, but if you wanted to check it across the others, you can see that it works as well. So it's 8 plus 3 is 11, and then 12 plus 3 is 15, and so on. So because I know that every term in this sequence is 3 more than its equivalent in 4n, I can then call this sequence 4n plus 3. and this is my nth term here, 4n plus 3. So later on, when I ask for the 50th term, I can then say n is 50 and do 4 times 50 plus 3. But I'll cover that in the next video anyway. So that would be 203. Okay, moving on then. Another example, finding the nth term here. The difference between it is 8. So I'm adding 8 each time. And I do it twice just to make sure that it is a common difference, that I am dealing with a linear sequence. And so now that I know it's 8 each time, I know that the times tables that relates to it is 8. So 8, 16, 24, and 32. Now when I compare both sequences, I can see that to get from 8 to 5, remember I only need to do it with the first number, is minus 3. So following on, 8, 16, 24, 32 is 8 times whatever position, n, which makes my first original sequence there 8 times n minus 3. One more example. Now this sequence shows us that the numbers are different, and when you compare them you can see that instead of what we did before where the values went up, our values are going down. So to get from 17 to 14, I am subtracting 3. To get from 14 to 11, I am subtracting 3, and so on. So what sequence do I know does that? Well, we could say the 3 times tables, but the 3 times tables increases in 3s. I'm looking for a times table that decreases in 3s, and so I'm going to do the minus 3 times tables. So if I show you minus 3 times 1 is minus 3, minus 3 times 2 is minus 6, minus 3 times 3 is minus 9, minus 3 times 4, minus 12. So we can call this sequence, like we have done before, minus 3 times its position, n. So now that I've got minus 3n, I need to then compare how I'm getting from my times table sequence to my original. What am I doing in each case? I only need to compare the first, and so I know that minus 3 plus 20 will get me 17. And you can, if you need to, use your number line and you'll see minus 6 plus 20 will get me 14, minus 9 plus 20 will get me 11, and so on. So my sequence on the top now becomes minus 3n times tables plus 20. Okay, with this negative here, you could have it on the other side as well. So it could be minus 3n plus 20, but equally 20 minus 3n. And you can see that it will work. So 20 minus 3 times 1 is 17. 20 minus 3 times 2 is 20 minus 6, which is 14, and so on. So these two are the same. Okay, so just to summarize, how do you find the nth term? You ask yourself a series of questions. First thing is, what does the linear sequence go up in? It only works for linear, and this one's going up in 2s. So that's the same as the term to term rule, going up in 2s. What sequence do we know increases by 2? It's the 2 times tables, which is also 2 times that position n. And what can I do to change 2 to 1? So how can I get from 2 to 1? And so from 2 to that one there, I minus 1. So it's always either a minus or a add. So in this case, I'm minusing 1 to get there. And that is it. Thank you